Okay, I've heard that you guys have started the Ohm's law in the class, right? So what I'm going to do is I'm going to kind of do a little bit of an introduction into circuits, because we are going to put some circuits up for the lab, and of course attach the instruments to measure the current and the voltage. We also have a variable resistor as a safety device for the circuit. Okay? We will have a DC battery, but instead of a battery, we have a power supply. Now, first off, when we talk about electricity, we have two types. One is, I went over this last week, but I'm trying to refresh it. Okay? Since this is the proper lab that deals with Ohm's law and current and voltage and all of this. Now, what we have is a DC or direct current. Now, in direct current, the current or the applied voltage from your power source, the direction of it, the positive direction, let's say it's positive, this side, is always going to be positive. It's not going to change. Now in the case of AC, your voltage directed this way gradually will change and eventually switch into this way. So at a certain instance, voltage will be positive this way, and then it will be negative. It will be pointing towards the negative direction. So that's why I have voltage switching back and forth, positive, and then it goes to negative, positive. So if you are measuring your polarity, in other words, whether this voltage is positive here, you will see that it won't stay positive at this point continuously. It will be positive and gradually drop to zero and then go to negative, comes back again and comes to negative. Back and forth, back and forth. You see this wave? Up, down, up, down. So it will point, the voltage will point positive, drop, zero, turns back, drop, zero, again pointing this way, positive, moves to both directions. In other words, if you are measuring your voltage here, it will be positive at a particular time, negative at another time. Okay? So that would be what we call alternating or AC current. Now, today what we have is a circuit that gets power from a battery or a power supply. And that is DC. Okay, so let's look at this circuit and let's try to identify the components. We have an ammeter. Ammeter measures the current. And we have a voltmeter that measures the voltage. So also we have a resistor as our device. And this is another resistor that is a variable resistor. And it's also called rheostat. It's a technical term. Okay? So now, how does this work? This is my power supply or battery. So what we have is a positive current that starts flowing in this direction, goes through the variable resistor, goes up, and as it goes up, it goes through the ammeter. Okay? Goes up, all these small arrows points to the direction of the current, and goes through the resistor right here. This symbol basically gives a resistor. This symbol right here gives a ammeter. This symbol right here gives a voltmeter. Okay? So now the current goes through the resistor, comes back out, comes back around through this conductive wire, goes back to the negative side of the battery or the power supply. Now they are not one and the same. You can think of this as a battery or a power supply, but they are not the same thing. Remember that. Okay? So now, I kind of conveniently didn't mention anything about this direction. Now these lines are conductive wires. So if you think about current as a water flowing through copper tubing or PVC tubing, current is flown through a conductive path, which usually is a wire. Okay? Now charge, the direction of the current as a convention starts from positive, goes to negative. In reality, that's not the case, because current flows through conductive wires, copper wires, by electrons. Now the electrons are negatively charged. So the true direction of the current would be this, because they start from the negative side and then goes to around the circuit, goes to the positive side. However, for all practical purposes, you can take this as a positive charge moving to the negative side, at least in your level. Okay? Now, why did I conveniently not mention this? Let's take a small example. Now, if you think about water, like I said, water that flowing through a tube system, that can be copper, can be PVC, doesn't matter. If you really want to measure the flow of water, you need to attach a meter so that the water flows through the meter, because you are measuring the rate of flow. Ammeter is such a device. It requires to be attached in a way that current flows through this. Okay? It has to go through this. And that is why I have to always attach my ammeter right here. Okay? Now, this, however, is my voltmeter. Think of the voltage as a pressure drop. Now, if you want to compare water with electricity and what is a pressure drop, think about your faucet. Okay? When the water comes out of the faucet and when you're washing your face in the morning before you came to the class, for example, water comes through the faucet, drops to the sink and gets drained down. So the pressure is high at the faucet, and at the drain bottom the pressure is low. Now in order to measure the pressure, we have to attach these two wires at the ends of the device across which the current flows. Okay? So when I attach this device, there's another thing that you have to remember. We are talking about this thing, and we talked, in other words, we mentioned this is a resistor. Now, resistor means it resists the flow of current. It's against the flow of current. Every device that we attach to a circuit, all these lights, your iPod, your computer, your music player, whatever you have, whatever you attach, your light bulbs, the stove, everything, in the simple sense can be considered as a resistor. I'm not going to make it more complex at this point. So all of these are resistors. Okay? So in that sense, what's going to happen is this. You have lots of resistors in a house or in a, in our school, for example. Now, they're important. They are needed. For example, we get light because of these, we get, all this light because of these bulbs. So in other words, they are important. However, they kind of restrict the flow of current. So we got to remember that. So in order to measure the flow of current, we have the ammeter here. For the voltmeter, it has to get attached to the two ends. That gives the drop in voltage. Now, to current to flow, if you think about water flows from top to bottom naturally. It has to be that way, otherwise water won't flow, right? So if you think about a free flow of water like a stream or a river, for example, it has to have a higher side and a lower side. Higher end is where the water starts, lower end is where the water flows to. So the same concept applies here. The current right here has to have a higher voltage in order for it to go through this resistor and come out this side. So in order to measure what side is higher in voltage, we have to attach our voltmeter like this. One thing I want to say is that, see that I did not put my arrows through this wire. Why is that? Voltmeter, theoretically, ideally, in our wishes, should have an infinite resistance, infinite obstruction to the flow of current. So if I have infinite resistance, that means no current flows through this. Now let's be honest, there will be a trickle of current that will flow through this. But for our purposes, we will say that no current flows through this. Okay? Now, what else that I want to cover here? Okay, positive and negative. See this battery or the power supply, if it's a DC power supply, one side is longer, one side is shorter. Okay, so ideally, this is drawn with a thicker line. Okay, this says that this longer line is your positive side. This is your negative side. This is a convention. You have to follow it. Okay. Resistor gives resistance. Don't forget that. What are we going to do today? We are going to verify Ohm's law. I think you guys have touched that in the class, the last class you had, right, on Wednesday. Now, Ohm's law states that voltage is proportional to current. And there's a constant. When you multiply that constant by current, you get the voltage drop. So if we have a current that flows through this resistor, if I multiply that current by the resistor's resistance, I get the voltage across this resistor. Okay? So, units. Voltage is measured by volts, current is measured by amperes. Now if you look at this, symbol for current is I, symbol for voltage is V. And if you look at the name for the voltmeter and then the units volt, they kind of relate to each other. And if you look at the ammeter, which measures the current, and look at the units, amperes, capital A, basically gives you what? The same kind of wording. Okay? Now, what are we going to do today? We are going to attach a power supply, and then what we are going to do is we are going to gradually increase the voltage of the power supply. And as we increase the voltage from this formula, if I increase the voltage, the current has to go up. If I increase the voltage, this is a constant. If I increase this, what's going to happen to this? Two sides are equal. One side you are increasing. What happens to the other side? What happens to the other side? If one side goes up, I'm sorry?
It also means
it has to go up. It has to go up. So in other words, current will go up. So what we are going to do is this. We are going to measure the voltage, and then we are going to measure the current across by reading values from our voltmeter and the ammeter. Okay? And then we are going to put about 20 data points. Because we're still lacking coffee today. No coffee. Makes you feel sleepy. Good coffee is good to go. You're having coffee. There you go. So let's see. Let's catch up again. So what we are going to do is we are going to measure voltage and corresponding current 20 times, and we are going to increase in steps of. I didn't mention that. We are going to increase the voltage value in steps. Steps of what? 0.1 volts. Okay? And you will get 20 data points. And you're going to plot them nicely on the graph. Your y-axis is the voltage. Remember to put the units. You need a title for this graph. Bless you. So, and of course you have current, and the units for the current is amperes. You need to have that. Now let's look at this. I'm not going to put the title, but you need to put a title. Don't forget that. So you are going to do a line fit, just like we did for the Stefan Boltzmann's law. And then from the line fit, you are going to read your slope and a y-intercept. And of course, I need the correlation coefficient R squared value as well. And then from this, if I look at this formula, V equals R times I, the way I have written, R times I. V is in my y-axis, I is in my x-axis. Therefore, my resistance is going to be what? Slope. Exactly. So that means if I read my slope, I can read my resistance. Okay? Two values, 30 and 60 ohms. This is what we are going to do. And we are going to find the resistance for both cases. And they are given to you as 30 ohms and 60 ohms. And you are going to compare what you get. For example, percentage difference is given by, of course, 30 minus what you get from the slope. It may be 31.2. It may be 29.1. It doesn't matter. Calculate the percentage difference. Acceptable values have to be less than 10% in difference. Okay? Now, same thing repeated for 60 ohms. How good is your data? Of course, if your data is acceptable, it has to be less than 10%. One other way to say this is to look at your data and see how linear your data is. Okay? And of course, look at the correlation coefficient. If your data is really linear, how much should the correlation coefficient be? We talked about it last week. If it's completely linear, close to 1. There you go. Perfect. Good. Your coffee is working. So, everything's good? Okay. So, we need to do it twice and get the percentage difference. And then we will do it twice. Good to go. Now, I've noticed that some of you don't do your analysis questions, or rather prediction questions very well. From now on, I'm going to cover that, give a couple of hints, kind of let you guys start thinking in a proper way so that you can get the answers for them better. Okay? So, let's get started. I think I'm supposed to work with you guys, right?
No.
With you? Okay. Let's get started.